Picture the world 10 million years after the asteroid killed the dinosaurs. The fires are long out. The ash has settled. The sun is back, and it never really left again, because contrary to what you have probably been told, the asteroid did not lock the planet into some permanent winter. It dimmed things for a while, and then the world went right back to being exactly what it had been before the impact: warm. Genuinely, persistently warm. No ice at either pole. Carbon dioxide levels already far above anything a human lung has ever breathed. Forests of mangrove and swamp and rainforest stretching across entire continents, dense but strangely uniform, dominated by only a handful of tree species, as if the planet's plant life had not yet finished deciding what it wanted to be. The animals living beneath that canopy were still small, still cautious, still recovering from the catastrophe that had ended the age of the dinosaurs. But they were growing. By the final stretch of this period, some of them had crossed the half-ton mark. The world, slowly, was beginning to feel stable again. And then, in a span of time too short to register on the body of any single animal alive at that moment, the temperature did something the planet's own climate record had never produced before in the entire span of this geological age. It did not warm gradually. It spiked, a sudden, violent vertical climb layered directly on top of a world that was already one of the hottest periods in the planet's deep history. Scientists call events like this hyperthermals. This one was the most extreme hyperthermal event of its entire era. Global average temperatures rose by approximately 8 degrees Celsius, and they rose fast enough that no ecosystem on Earth had any meaningful warning before it hit. The baseline world average before this happened was already close to 28 degrees Celsius, a climate already considerably hotter than anything most of the planet experiences today. After the spike, estimates placed the new average closer to 34.5 degrees. Hot enough that the high latitude seas near the poles, water that should, by every rule of planetary physics, have been frigid, instead sat at temperatures more typical of a warm subtropical coastline. This is the Paleocene-Eocene Thermal Maximum. For the next 200,000 years, the entire surface of this planet became something closer to a single, continuous, overheated jungle than anything that had existed since the deep distant swamps of the Carboniferous, hundreds of millions of years earlier. And nobody, not one living thing on the surface of this planet, had any idea why it was happening to them, or when, if ever, it would stop. Here is the part of this story that should genuinely unsettle you. Scientists studying the deep rock record of this event know, with total confidence, that an almost unimaginable quantity of carbon dioxide was injected directly into the atmosphere in a geological instant, concentrations climbing to more than 4 times the levels already present in that already carbon-rich world. And after decades of research, there is still no settled answer for exactly what caused it. The list of suspects reads like the contents of a planetary horror anthology: catastrophic volcanic eruptions on a scale almost impossible to picture. Vast underground deposits of ancient organic peat, igniting and burning for centuries beneath the surface, undetected, unstoppable. A sudden and violent reorganization of deep ocean currents, releasing frozen methane that had sat stable on the sea floor for millions of years. Even, in some hypotheses, a direct impact from beyond the planet entirely. Every one of these explanations has supporting evidence. None of them has been confirmed beyond doubt. Something happened to this planet 55.8 million years ago that was severe enough to leave a permanent, unmistakable scar in the deep rock record on every continent on Earth, and the planet itself has never told us, conclusively, what it was. What is not in question is what that injection of carbon did to the world above it. The heat did not arrive alone. It brought water with it, evaporation rates climbing sharply, especially across the tropics, rainfall intensifying to levels that turned already lush forest into something closer to permanent flood. Tropical and subtropical forest did not simply intensify where it already existed. It expanded into territory that, before this event, had never supported anything like it and would never support anything like it again. Regions that would one day become some of the driest landscapes on the continent were, during these 200,000 years, blanketed in dense tropical rainforest. At the opposite end of the planet, in the territory nearest the poles, palm trees grew alongside cold climate vegetation that should have had no business sharing the same forest floor. Sea levels rose. Swamps swallowed lowland after lowland. The entire surface of the planet, for 200,000 years, became something close to a single continuous wetland forest stretching from one pole to the other, an environment with almost no precedent anywhere else in this planet's 4.5 billion year history, except for one other terrifying chapter, hundreds of millions of years earlier, when the world had briefly looked something like this before. And this transformation did not just rearrange the scenery. It rewired the evolutionary trajectory of nearly every major animal lineage alive at that moment, including the one that would, tens of millions of years later, eventually produce you. Here is the detail almost nobody talks about when they discuss this event: the heat did not affect every animal the same way. It split the surviving world into two opposite evolutionary directions, and the dividing line was something as simple and as old as whether an animal generated its own body heat or borrowed it from its surroundings. Warm-blooded mammals, almost without exception, began to shrink. A body that manufactures its own internal heat is a body that is constantly fighting to release excess warmth in conditions like these, and the most efficient solution evolution had on hand was simply to become smaller, less mass to keep cool, less metabolic furnace running at full output in a world that had already turned into an oven. Across this 200,000-year window, mammal lineage after mammal lineage shrank, and in shrinking, many of them split into a wider range of distinct forms than they had ever produced before, small bodies adapting in slightly different directions to slightly different pockets of an increasingly crowded, increasingly competitive forest floor. It was during this exact window of heat and shrinking that several of the mammal lineages that would eventually fill the modern world first appeared in any recognizable form, the earliest ancestors of horses, rhinos, and tapirs. The earliest ancestors of the entire lineage that would one day include camels, deer, cattle, and, through a separate and far stranger branch, whales. And in the dense, overheated canopy above the forest floor, the first true proto-primates, small, large-eyed, long-tailed climbers that looked far closer to a modern lemur or even a squirrel than to anything you would immediately recognize as a relative. None of these animals were giants. Most of the hoofed mammals moving through this transformed world were small enough to be lifted with a single arm, compact, four-legged, almost indistinguishable from each other across different lineages, none of them yet carrying the horns, the snouts, or the distinctive skull shapes that would eventually separate horses from rhinos from tapirs in the millions of years still to come. Their small size, in this specific moment, was not a weakness. It was the single advantage that let them survive the heat at all, smaller bodies running cooler, and small enough besides to disappear completely into the dense undergrowth the heat itself had produced. Cold-blooded reptiles experienced something close to the exact opposite. An animal that draws its body heat from its environment suddenly found itself standing in an environment radiating more usable energy than it had ever had access to before, heat that, for a warm-blooded mammal, was a constant metabolic threat, but for a reptile was free fuel requiring no food at all to acquire. Across this same 200,000-year window, reptile lineage after reptile lineage did not shrink. They grew. Turtles reached sizes far beyond anything seen in the periods immediately before or after. Snakes, particularly those already living in water, ballooned into something close to legend, serpents stretching past 12 meters in length, patrolling the warm shallow seas surrounding entire continents, the largest snakes that have ever existed on this planet, before or since. And on land, several distinct lineages of crocodile-like predators abandoned the water almost entirely, evolving longer legs, more upright postures, and a fully terrestrial hunting lifestyle, land-walking, land-running predators wearing a crocodile's armor and a crocodile's jaw, stalking a heat-soaked forest floor that had no rivers anywhere near it. The result was a world that violated almost every assumption you have been taught about which era belonged to which kind of animal. This was supposed to be the age of mammals. And in the dense, dripping forests of this 200,000-year window, mammals were everywhere, diversifying, multiplying, filling every available niche the canopy could offer. But in many of those same forests, at the very top of the food chain, the animal making the final decision about who lived and who didn't was not a mammal at all. It still had scales. Beneath that canopy, the food chain had organized itself into a hierarchy that would have looked deeply unfamiliar to anything alive today. At the smaller end, weasel-like and squirrel-like carnivores moving through the branches, picking off insects, small birds, and anything else too small to defend itself. Slightly larger, flat-footed, otter-like and badger-like hunters, roughly fox-sized at their largest, more numerous than dangerous. And moving with a quiet, efficient stride that almost nothing else in this forest could yet match, an early lineage of wolf-sized, flesh-shearing predators whose running ability was, for this exact moment in evolutionary history, genuinely without precedent. Most mammals alive at this time were still slow. These were not. But the true apex predators of this transformed world belonged to a lineage that would not survive much longer past this exact window, wolf-like, heavily built, carrying jaws engineered not just to tear flesh but to crush bone outright, extracting marrow that lesser predators could never reach. One species among them grew to a size that had no rival anywhere else in this ecosystem, an animal weighing close to 400 kilograms, an apex killer whose worn teeth tell us it processed bone as a routine part of its diet, not as an emergency fallback. For every other predator and every other prey animal sharing this heat-soaked forest, this was the single most dangerous thing that could appear at the tree-line. And yet this same lineage, despite its size, despite its dominance, despite outlasting nearly every other group of predators competing against it, would not survive the heat that had briefly made it the most fearsome thing on the continent. It had evolved tens of millions of years earlier, in a cooler world built for a different kind of body. The heat of these 200,000 years did not destroy it instantly. It simply made survival, generation after generation, marginally harder than the last, until the lineage that had briefly stood at the absolute top of this transformed world quietly disappeared before the heat itself had even finished. This is the detail worth sitting with longest. In this story, being the strongest, the largest, and the most dominant predator in the entire ecosystem was not a guarantee of anything. It was simply a temporary position, rented from a climate that had no loyalty to the things it had briefly made powerful. And even the animals that managed to grow large enough to deter every predator in this forest, plant-eaters reaching the size of a small pony, heavier than anything that had walked the land since the asteroid ended the previous age, were not doing it from a position of comfort. They were doing it because, in a world this hostile, size itself had become one of the only forms of safety left. If the forests of this world were merely dangerous, the oceans beneath this same heat wave were undergoing something closer to a slow, silent collapse. As the seawater warmed, it began to separate into distinct, stable layers, and the deepest of those layers, cut off from fresh oxygen exchange with the surface, slowly turned anoxic. Lifeless. A spreading, invisible death zone advancing through shallow seas and coastlines around almost the entire planet, hitting the smallest, most fragile bottom-dwelling organisms hardest of all, in some regions, wiping out a greater proportion of seafloor life than even the asteroid impact that had ended the age of the dinosaurs 10 million years earlier. At the same time, the ocean's chemistry itself began to turn against the creatures living inside it. Carbon dissolving directly into seawater dropped its pH measurably, not enough to be obvious to anything swimming through it, but enough to begin dissolving the very carbonate shells and skeletons that countless marine organisms depended on simply to exist. And yet, somehow, in the middle of an ocean actively turning hostile to nearly everything living inside it, certain predators thrived as though the chaos itself were an invitation. Sharks expanded their range to nearly every corner of the warming planet, hunting in waters as far north as territory that should have been frozen solid. Most of them were recognizable forms, ancestors of species that exist today. A few were not. Among the largest predators alive anywhere on Earth during this entire 200,000-year window was a shark stretching close to 9 meters in length, not simply one of the largest predators in the ocean during this period, but quite possibly the single largest predator anywhere on the planet, in water or on land, for the full duration of this event. Alongside it, fully marine crocodiles with long, thin, blade-like snouts, built for a fast, efficient bite rather than a crushing one, some stretching past 6 meters, ranging through nearly every body of water on Earth, saltwater, brackish, and freshwater alike. And patrolling the same warm, oxygen-starved shallows, the same gigantic constricting sea snakes that had grown to legendary size on land's borders, drifting now through water that, in its depths, had quietly become a grave. There was, in the end, no truly safe direction to move during these 200,000 years. Too far inland, and the heat itself, the swelling reptiles, and the bone-crushing apex predators of the forest floor were waiting. Too far into the water, and an invisible, oxygen-starved death zone was spreading silently beneath a surface that looked, from above, like nothing more than a calm and inviting subtropical sea. And then, after 200,000 years, a span of time longer than every glacial cycle of every more recent ice age combined, achieved in roughly a 30th of the time those slower changes once took, it simply stopped. Not because anything intervened. Silicate rock, weathering slowly across every continent, began drawing carbon back out of the atmosphere in quiet, continuous chemical reactions. Dead organic matter, sinking and burying itself in sediment layer after sediment layer, locked enormous quantities of carbon back into the crust of the planet. The temperature began, slowly, to fall back towards something the world had known before. It would never fully return to where it started, and within a few million years, in a final cruel echo of the same mechanism, the planet would do something disturbingly similar to this all over again. But for the animals who had lived through this specific 200,000-year window, the dwarfed mammals who had shrunk to survive it, the swollen reptiles who had grown enormous because of it, the apex predator that had briefly ruled an entire continent before quietly vanishing from it, the worst of it, for now, was finally over. The world had tried, for 200,000 years, to cook itself alive. And the animals that made it through to the other side were never the strongest. They were simply the ones whose bodies happened, by pure chance of biology, to bend in whatever direction the heat demanded of them. If this story stayed with you, drop a comment and tell me which detail you're still thinking about, the apex predator that ruled an entire continent and still didn't survive the heat that made it possible, or the ocean's invisible death zone spreading silently beneath a calm subtropical surface. And tell me where in the world you're watching this from.